Hello, I welcome you all to this another interesting screencast. The problem reads: two electrically charged pith balls, each having a mass of 0.2 grams, are suspended from light threads of equal length. Determine the resultant force of repulsion acting on each ball if the measured distance from them is r equal to 200 millimeters. This particular problem is just coming from the engineering mechanics and statics textbook, the 10th edition by R.C. Hibbeler. Right, so let's draw the free body diagram. So let's call this point here point 1, this one here 2, and then this point here 3, this one here 4, or maybe not like this. Let me say 1, then this one here 2, this one here 3, this one here 4. Right, so been told each particular pith ball has a mass of 0.2 grams. So let's convert that to the weight. So I'll have weight on each of these balls, and there is symmetry there, so we'll not work on all of them, we just work on one. So this is 0.2 times we need to convert it to kgs, so 0.2 divided by 1000, because this is in grams, so we need to convert it to 1000, to convert it to kgs, then times 9.81, because 1000 grams make 1 kg, right? So what do we have? So 0.2 divided by 1000 times 9.81, so we have 1.962 to the power 10 to the power minus 3 newtons. So this is the same value also here. All right, it's the same value. Great. And we are going to have, let's cut these particular cables. We cut them there, like so. So once we do so, then we'll have a tension force like so and like so, and the same appears to the other side there, like so. I'm just showing this, we don't need to work on both of them because they are symmetrical. Okay, they are symmetrical about the horizontal, the vertical axis, about this axis here, there is symmetry, right? Okay, and this component will have two, this component that I'm going to call, this one I'm going to call F. This will be my F1, 2, and this one here is my F3, 4. Okay, so it is going to have some components. One component will be in the horizontal like so. Okay, and the other one will be vertical like so. Okay, and the same appears to there like so. All right, you don't have to do this for both of them, you can just work on one. Okay, I'm just showing this. So this is equal to so let's find the slope. The slope for this, if you look at this, let me just draw down. We need the slope. This is this distance here from here to there. Okay, this one there, and then we are also going to so this one here is equal to this distance here. Let me clean up this a little bit. Okay, great. So that distance there, this one here is equal to 200 200 minus 50, then everything divided by 2. Okay, is that fine? So 200 minus this, then divided by 2. Then this becomes, as 200 minus 50 divided by 2, this becomes 75 millimeters. Right. So this slope is equal to, let's write it down. This slope is equal to this slope is equal to, let's write it down. Great. So the height of this is equal to, has the height been given? So we have this, and then this point here, we need to find it. We need to find that particular point there. How do we find it? This is R, this is so we can find it. So we need to find this height here. Let's do so. You can use Pythagoras, right? So let's find this height. Great, let's find this height. Let's find that height. You can use Pythagoras. So let's do so. So we have 150 squared minus 75 squared square root will give us that value, right? Remember, 150, because we are looking at a triangle like this. Okay, this whole length is equal to 150, and then this one there is equal to 75. Okay, so we want to find this is what we want to find. Okay, so 150 squared minus 75 squared square root of that gives us a 129.9. Okay, I'll just put it, no, about 130. So round it off to just 130. Okay, 130. Okay, 150 squared minus 75 squared square root 129.9, round off to 150. Okay, 130. So we have that. Therefore, our slope, we'll say this slope here, the height is 130, or we can convert it to meters, but we can leave it like this. It's no big deal because this is just a slope. And then the run is 75. Therefore, this hypotenuse here remains as 150 for now. Nothing changes. It's just supposed to give us the same things, right? Okay, supposed to give us the same things. Okay, 150. So now let's now label this force. Therefore, this one is equal to, you can label it just there, this is equal to F12 by F12 by F12 by the rise, which is 130 divided by 150, and then this one is F12 by the run, which is 75 divided by 150. So the same appears that side. So just concentrate on just this. It will have the same results the other side. Right, so now let's sum up the forces. We start with summation of forces in the x and in the y, doesn't matter which order. So summation of forces in the x going in this direction being our reference. What do we have? We have 75 minus F equal to 0, and therefore F is just going to be equal to 75. Okay, sorry, let's sum up the forces. So we have summation of forces in the x equal to 0, going in that direction being our reference. This direction, what do we have? We have F12 by 75 divided by 150. Then multiply this in advance. Put the number in front. 75 divided by 150 times F12 minus F equal to 0. Okay. And then we have summation of forces in the y equal to 0, going up in our reference. We have F12 130 divided by 150 F12 minus 1.962 10 to the power 3 equal to 0. Therefore, F12 is just going to be equal to what is our F12? So we have 1.962 times 10 to the power 3 divided by 130 divided by 150. Alright, so we have a 2.26 10 to the power negative 3. Alright, and then we can feed this into here. We know what we can feed this particular so that we find the value of F. So feed this here, and once we do so, the value of F therefore is just going to be equal to this value times 75 divided by 150. This just becomes a 1.13 to the power 10 negative 3. Okay, newtons. Alright, we found the resultant horizontal force F acting on each ball, which is a 1.13 10 to the power 3. Yeah. So I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast. So this F is the same on both cases. Okay.